So let's now talk about some application problems. In other words, real world problems. In other words, word problems. So there's lots of different ways to call it what it is. So we're going to write an algebraic equation. That means we're going to have a variable and all that other fun stuff for the real world situation and use those properties of equality to find the value of the variable. We need to make sure we show every step. Okay? All right, so look at number 7. Number 7, we have 3 friends went to a band party at a local farm. Each student spent the same amount of money and a total of $21 all together. Each student bought a hot dog. I know it says hot do, but it's hot dog for $5. If they each also bought a hayride ticket, how much did each hayride ticket cost? So let's first write our let statement. So our let statement is just something to tell us what the variable is going to be and what it represents. So I'm going to switch to a text box and I'm going to type in here let I don't know. I guess we could choose. How about the letter T? Equal the cost of hayride ticket. Okay? So now we've decided what that is going to be. And hold on just a second. All right, sorry about that. I spilled my drink, but I cleaned it up and now I'm ready to rock and roll. All right, so I wrote my let statement. Now, what I want to do is I want to just kind of understand it conceptually, kind of, create like a skeleton of my equation before I put in the when I put the fine finish touches on it, I guess I should say. All right, so let's kind of understand this. One thing we're going to need to know is we're going to need to know the total. And I always, because this is just me, but I recommend it, I always put my total on the right-hand side of my equal sign. Everything else is going to go on the left. So my variable, along with all the other parts that go along with that, are going to go on the left-hand side. I never put my variable all by itself on one side when I'm writing the equation. I put my total on the one all by itself, and then the variable with all the other stuff goes on the other side. All right, so looking at what we've got 3 friends that are going, and we need to take into account how much each of them has spent. So what I'm going to do, that means what I'm going to do is I'm going to have parentheses. Inside of the parentheses is what each person is responsible for, or each person pays. So this is per person, what they pay. And then what I'm going to do is I'm going to multiply all that they pay for each person times the number of people that go. So in other words, the number of people is what goes on the outside. Now, looking at what each person buys, well, each person buys a hot dog and each person buys a hayride ticket. So I'm going to put HR ticket to represent the hayride ticket, plus they buy a hot dog. So, hot do. So there's my bare bones. I know it's hard to really look at it and see, but there's my bare bones for my equation. So now I'm going to go back in and I'm going to substitute in some numbers. The number of people that went is 3. The cost of the hayride ticket, I don't know what that is. That's my let statement. So that's going to be my variable T. And then the cost of the hot dog, which is $5, is equal to the total. How much did they spend all together? 21 bucks. There's my equation. So now what I'm going to do is I'm going to solve it. But before I do that, I am going to highlight my equation. So that way I can identify my equation. So 3 times t is 3t. 3 times 5 is 15. Added inside the parentheses, added outside the parentheses, and all of that is equal to 21. Subtract 15 from both sides. That gives me, cancels out my 15s, leave me with 3t is equal to 6. Divide both sides by 3. So the cost of the hayride ticket is $2. Okay? That's all there is to it. But I know it takes a little bit of time to get into that pattern and see that strategy can develop. So we're going to go ahead and do the next one, number 8, together. Mr. Vargas takes his class of 24 students ice skating. Each student pays an entrance fee to enter the rink. And, excuse me, $4.75 fee to rent skates. The total cost of the students to enter the rink and rent skates is $234. What is the ice skating rink's entrance fee? So the first thing I'm going to do is I'm going to change to a text box and I'm going to write my let statement. So let's see, we need to find the entrance fee. So I'm going to make it E. No, F. Let F equal the cost of the rink's entrance fee. Okay, so I know when I look at my equation, F is going to represent the cost of the ink fee. All right, so just like in the last question or last one, I'm going to put my equals and my total. So right now we're just building it conceptually, and then we'll fill in with our numbers. Okay, just like what we did on the other one, what each person pays is going to go in the parentheses. So each person, or per person, however you want to say it, means the same thing. And then the number of people that are going is what's going to be multiplied to it. All right, looking at what each person has to pay, they have to pay the entrance fee, which I'm using the letter F to represent. Oops, I'm sorry. All right, the entrance fee, so I'm just going to put ENT fee plus the renting fee of the skates. So now we've got that conceptual understanding of it. We're going to go ahead and finish it up. So 20 number of people, 24. The entrance fee, we don't know what that is. That's going to be my letter F. The rent for the skates is $4.75 equals the total, which is $234. All right, pause the video, finish it, and then come back and check your answer. Did a bad thing. I accidentally see when I went up to pause my video, I accidentally hit stop. So now we have 3 videos for this lesson as opposed to just 2 videos. Maybe I can splice them together. I don't know. It depends on if I'm feeling up to doing that before I go to bed. I don't know. We'll see. Anyway, in the long and short of everything, I ended up with $5 for the entrance fee. All right, moving on down. This is the last one we're going to do. We're not going to do number 10 because as I was working it, it felt like there was something missing. I went and checked the book, and there is indeed missing information. So we cannot solve this one. So we're going to go ahead and just skip number 10. So number 9 is the last one. Mackenzie drives the same distance to and from school each day. She also drives 1 3/4 miles round trip each day to go to the library. During a 5-day school week, Mackenzie drives a total of 50 miles. Write and solve an algebraic equation to determine the total distance to and from the school. All right, I really want you to give this one a try on your own. Okay, so we're going to pause the video again. This time I promise I'm not going to hit stop, but pause the video, try it, and then come back. Okay, I hope you got this. So in the end, I got 8.25 miles or 8 and 25 hundredths of a mile to and from school. So this is how I developed it. I put the number of days of school, or the number of days of driving. In parentheses, I put how much per day. And when she goes per day, when she drives per day, it's to school and back and library. So that's what it goes inside of the parentheses. And then I put equal sign and then the total amount she drives in that whole 5 day period. So building in or plugging in our values, we have the number of days is 5. The distance to and from school, that's what I don't know. That's what my variable is. So that's D, plus the distance to the library, which is 1 3/4 mile to the library. And then all of that is equal to 50. So do my distributive property, which gives me 5D plus 8 and 75 hundredths is equal to 50. Subtract 8 and 75 hundredths from both sides. That gives me 5D is equal to 41 and 25 hundredths. Divide both sides by 5. And that gives me 8 and 25 hundredths, or in other words, 8 1/4 miles. All right. I hope you guys did well. Good luck on the practice, and catch you on the flip side.